NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this lesson, we will build an intuitive cheat sheet of logarithm properties. We'll move step by step with visual rule cards and quick numeric examples. Let's begin with the two most fundamental facts. First, the logarithm of 1 is 0. Second, the logarithm of the base is 1. Next, product and quotient rules. Product turns into addition. Quotient turns into subtraction, and a reciprocal flips the sign. A quick example in base 10. Log 10 of 5 equals log 10 of 10 over 2, which is 1 minus log 10 of 2. Power rules. An exponent on the argument becomes a multiplier. An exponent on the base becomes a divisor. Together, m over p appears. The root versions are just fractional exponents. Change of base and reciprocity are the power tools for switching bases. The product of log b of a and log of b equals 1. And log base b of a equals log base c of a over log base c of b. Two lovely exponential identities. First, n equals a raised to log base of n. Second, x to the log base I of y equals y to the log base of x. Example. We will evaluate the expression 49 to the power 1 minus log base 7 of 2 plus 5 to the power negative log base 5 of 4, following the exact sequence shown on screen. Step 1. Rewrite 49 as 7 squared, power of a power, and use the negative exponent rule to turn 5 to the minus log base 5 of 4 into 1 over 5 to the log base 5 of 4. Now display the rule box and write the transformed line. Step 2. Distribute the 2 across the parentheses in the exponent. We'll note the distribution. Now write the line exactly as shown. Step 3. Use the exponent subtraction rule to rewrite 7 to the 2 minus 2 log base 7 of 2 as 7 squared divided by 7 to the 2 log base 7 of 2. Also, 5 to the log base 5 of 4 equals 4. Show the rules. Now the line. Step 4. Use the power rule of logarithms to turn 2 log base 7 of 2 into log base 7 of 2 squared, which is log base squared, which is log base 7 of 4. Show the rule box. Then write the line. Step 5. Evaluate 7 squared as 49 and simplify 7 to the log base 7 of 4 to just 4. We recall the identity. Now show the numeric fraction. Step 6. Add the fractions with a common denominator of 4. Getting 50 over 4, and simplify to 25 over 2. Show the fraction addition rule. Add the numerators. Reduce the fraction to its simplest form. Finally, present the answer. Let's display the example and the target expression. Step 1. Introduce a helper variable x and take the logarithm of both sides. We'll use the idea of introducing a variable. If x equals the whole expression, then log x equals the log of that expression. Quick challenge. What rule will we apply next? Step 2. Apply the power rule of logarithms. The power rule says log of m to the k equals k times log of m. Using that, we get log x equals the fraction log of log over log a times log a. Step 3. Simplify by canceling matching factors. When a over b multiplies b, the b cancels, and we get a. Therefore, log x equals log of log a. Step 4. Remove the logarithms by equating their arguments. If log of a equals log of b, then a equals b, assuming equal bases and valid domains. Hence x equals log a. That is our final answer. Example. We will evaluate the expression log base x of the square root of x times the cube root of x times the fourth root of x. Along the way, we will convert roots into fractional exponents, combine powers, and then use the power rule for logarithms. Quick note on the domain. For a logarithm with base x, we must have x greater than 0 and x not equal to 1. Step 1. Convert the innermost fourth root to a fractional exponent. The fourth root of x equals x to the 1/4. Step 2. Combine the product x times x to the 1/4 inside the cube root. Add the exponents. 1 plus 1/4 equals 5/12 after the cube root, but first inside the cube root it is 5/4. Step 3. Apply the cube root. Raising x to the 5/4 to the 1/3 multiplies the exponents. 5/4 times 1/3 equals 5/12. Step 4. Now combine x to the first with x to the 5/12 before taking the outer square root. Add exponents. 1 plus 5/12 equals 17/12. Step 5. Apply the square root, which is the 1/2 power. Multiply exponents. 17/12 times 1/2 equals 17/24. Step 6. Use the power rule of logarithms. The exponent comes down in front. Step 7. Because the base and the argument are the same, log base x of x equals 1. So the value is 17/24. Example. We'll follow the exact step order shown in the provided solution text. The given statement is, if log sub a b of a equals 4, find log sub a b of the cube root of a divided by the square root of b. Step 1. Start from the identity. The logarithm of its own base equals 1. Step 2. Expand the left side using the product rule of logarithms. Step 3. Substitute the given value log sub a b of a equals 4. Step 4. Solve for log sub a b of b by subtracting 4 from both sides. Now evaluate the target expression exactly as written. Step 6. Apply the quotient rule to split it into a difference of 2 logarithms. Step 7. Use the power rule to bring the fractional exponents out in front. Step 8. Substitute the two values we now know, 4 and -3. Finally, compute the arithmetic to reach the result 17/6. Example. We will follow the exact sequence of steps from the provided solution. Given log base 12 of 27 equals a. Our goal is to express log base 2 of 3 in terms of a and then compute log base 6 of 16. We begin exactly as in the written solution. Step 1. Step 2. Step 3. Step 4. Step 5 uses the reciprocal change of base rule. Step 6 factors 12. Step 7 applies the product rule. Step 8 applies the power rule. Step 9 notes log base 3 of 3 equals 1. Step 10 isolate the remaining term. Step 11 solve for log base 3 of 2. Step 12 convert to log base 2 of 3 using the reciprocal rule. Now we compute log base 6 of 16, again matching the written steps. Step 13. Step 14. Step 15. Step 16 uses the reciprocal change of base. Step 17 factors 6. Step 18 uses the product rule. Step 19 uses the base rule. Step 20 substitutes the expression for log base 2 of 3. Step 21, 22, and 23 simplify the complex fraction to the final form. Example. We are given that log 5 equals a. Find log base 8 of 100. We will follow a clean step-by-step path and use only the usual log rules: quotient rule, power rule, and the change of base formula. Step 1. Start from the given statement. Next, rewrite 5 as 10/2. Apply the quotient rule. Log of a fraction equals log numerator minus log denominator. Since log 10 equals 1, we obtain 1 minus log 2 equals a. Finally, isolate log 2. Now we compute log base 8 of 100. Use the change of base formula. Rewrite 100 as 10 squared and 8 as 2 cubed. Apply the power rule to bring exponents out front. Substitute log 10 equals 1, and our earlier result log 2 equals 1 minus a. Then simplify to the final compact form. Recap. From log 5 equals, we express log 2 as 1 minus a, using change of base, and the power rule, we reduced log base 8 of 100 to 2 divided by 3 times 1 minus a. That's our final answer. In this example, we will express log base 3 of 2 in terms of a, given that log base 12 of 27 equals a. Step 1. State the given relation. Step 2. Use the reciprocal form of the change of base formula. The log base 12 of 27 equals implies log base 27 of 12 equals 1 over a. Step 3. Factor 12 as 4 times 3. Step 4. Apply the product rule for logarithms to split the single logarithm into a sum. Step 5. Rewrite 27 as 3 to the third power and 4 as 2 squared. Step 6. Use the power rule for logarithms with powered bases and powered arguments. Step 7. Evaluate log base 3 of 3, which equals 1. Step 8. Isolate the term with log base 3 of 2 by subtracting 1/3 from both sides. Step 9. Multiply both sides by 3 halves. Step 10. Simplify the algebraic expression to finish. The result is left parenthesis 3 minus 9. Multiply both sides by 3 halves. Step 10. Simplify the algebraic expression to finish. The result is left parenthesis 3 minus a right parenthesis over 2a. Recap. We use the reciprocal change of base, the product rule, rewriting as powers, the power rule, and simple algebra to isolate the target expression. Here is the example we will follow step by step. Step 1. Start with the given equation exactly as written. Step 2. Multiply both sides by 2. Then write the result. Step 3. Use the power rule. A times log of b equals log of b to the power a. Now move the 2 inside the logarithm as an exponent. Step 4. Square the fraction and use the product rule on the right side. Then write the simplified equality. Step 5. Since the logs are equal, their arguments must be equal. Write the result without logarithms. Step 6. Multiply both sides by 9. Step 7. Expand the square of a binomial. Then write the expanded equation. Step 8. Subtract 4xy from both sides to isolate the requested expression. Finally, we get the compact result. Therefore, following the exact algorithm and step order, the final expression is 4x squared plus y squared equals 5xy, the requested expression. Finally, we get, in this example, we'll follow the steps exactly as shown to express 2 base 10 logarithms in terms of m and n. We are given that log base 10 of 2 equals m, and log base 10 of 3 equals n. We must find log base 10 of 18, and the sum log base 10 of 32 plus log base 10 of 27. Part 1. Compute log base 10 of 18. Step 1. Write the expression. Step 2. Factor the argument as 9 times 2. Step 3. Apply the product rule for logarithms. The log of a product is the sum of the logs. Step 4. Write 9 as 3 squared. Step 5. Apply the power rule, bring the exponent out front. Step 6. Substitute the given values for m and n to finish. Therefore, log base 10 of 18 equals 2n plus m. Part 2. Compute the sum log base 10 of 32 plus log base 10 of 27. Step 7. Write the expression. Step 8. Express each number as a power. 32 is 2 to the 5th, and 27 is 3 to the 3rd. Step 9. Apply the power rule to each term. Step 10. Substitute the given values to conclude. So the sum is 5m plus 3n. Recap. We use the product rule to split a product into a sum of logarithms and the power rule to bring exponents down as multipliers. Those 2 rules, plus substitution, gave the final expressions. Step 1. Use the product rule by writing 28 as 2 times 14. Step 2. Since log base 14 of 14 equals 1, we have it equals 1 plus log base 14 of 2. Step 3. Isolate log base 14 of 2 by subtracting 1 from both sides. Step 4. Apply the reciprocal property of logarithms. Log base b of x equals 1 over log base x of b. This gives log base 2 of 14 equals 1 over a minus 1. Step 5. Expand the left-hand side using the product rule again, writing 14 as 2 times 7. Step 6. Since log base 2 of 2 equals 1, move that 1 to the right to isolate log base 2 of 7. Step 7. Combine the right side into a single fraction. Step 8. Take the reciprocal to switch base and argument and obtain log base 7 of 2. Final steps. Rewrite 49 as 7 squared and 16 as 2 to the 4th. Then use the power rule for change of base. Combine the right side into a single fraction. Step 8. Take the reciprocal to switch base and argument and obtain log base 7 of 2. Final steps. Rewrite 49 as 7 squared and 16 as 2 to the 4th. Then use the power rule for change of base. Show the example statement. Step 1. Start with the given equation. Say, log base a of 27 equals b. Step 2. Express 27 as 3 cubed. Show the rule box. Replace 27 by 3 to the 3rd power. Step 3. Apply the power rule of logarithms. The exponent comes down as a multiplier. Show the rule box. That yields 3 times log base of 3 equals b. Step 4. Isolate the logarithm term by dividing both sides by 3. Show the division property. So, log base of 3 equals b over 3. Step 5. Use the reciprocal property of logarithms to flip base and argument. Show the reciprocal property. Therefore, log base 3 of equals 3 over b. Step 6. Evaluate the target expression log base square root of 3 of the sixth root of a. First, rewrite the base and the argument using exponents. Then, apply the generalized change of base rule. Simplify the fraction of exponents. 1/6 divided by 1/2 equals 2/6. Reduce 2/6 to 1/3. Substitute log base 3 of it equals 3 over b. The result simplifies to 1 over b. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.